Okay, I know we have a busy agenda, so I'll try to be quick today. We've talked before in the past about stride-agnostic PyTorch. PyTorch Infallible Views is one of three parts of that. The idea here is that the view operator will sometimes fail. The situations under which it can fail can be somewhat difficult to describe in general terms. I'll go to a few examples in a moment, but the idea here is that we would be extending support to the view operator to work in those cases, and we can't do that with the standard strided view representation. So we have to effectively have a new implementation in order to deal with these cases. Let's just jump to a couple of simple examples to see like under what circumstances view can fail. So here's a really simple one. We just have a 4-element tensor. If we put it in a 2x2 view and then transpose the dimensions, and then try to view it as a 1D tensor again, it will fail. And here's what it would look like if we had an infallible view implemented. And you can see that this is not something that could be represented with the standard strided view. A slightly more complicated case is this one right here. Here we're going to do 2 infallible views. So we have 15-element tensor, transpose view it 3x5 and transpose the axes. Then we project it back into a 15-element 1D tensor, and then do a 3x5 view on that. And you'll see that this is a very odd striding going on here. The question ultimately becomes is like, can we express these views with in simple mathematical terms? We don't know the answer to that yet, which is what the rest of the doc is mostly going to be dealing with, is how we're going to implement it otherwise. An important thing to consider here is that we want to unblock stride agnostic PyTorch as quickly as possible. So we want to, we're mostly concerned with just getting this working. One thing that is like strongly in our favor here is that because this doesn't work today, we don't have to worry too much about performance immediately, because no valid PyTorch program is doing this. There is, I mean, we obviously are concerned about making performance for things that don't use this unaffected, and that should be easy to achieve. But we do have maybe more of there's like a theoretical concern about like, if you have multiple layers of these infallible views, what's the performance of that going to be? It's not a high priority right now, but that's kind of where we're at. So there is some inspiration for view-like operations that are that have a special implementation. We have 2 unary view types. We have a negative view and a conjugate view. These are interesting cases. They're both implemented by having a special dispatch key. And when that dispatch key is matched, it will materialize the views by applying the unary operator. These cases turn out to be much simpler than the infallible view case for 3 reasons. For a few reasons. So the main reasons being that they're their own inverses. So to undo a negative view or undo a conjugate view, you just apply the operation again. They only require a single bit of storage, and conveniently we just use the dispatch key there for that. And then also they don't do anything to the shape of the tensor, which limits kind of the blast radius of what needs to change for them. The infallible view machinery unfortunately doesn't have those characteristics. The the two. I mean, logically, the you could say that the it's its own inverse in the sense that you can reshape back and forth between them, but you do have to remember what the original state original shape was in order to reshape back. This is this is probably like where like kind of like the first major piece of complexity comes in. So the implementation approach that we're currently looking at here is we're still going to use the dispatch key mechanism in order to apply the transformation. But we have to add additional state in order to track the in order to keep track of like what the new size is, what the old size was, and we're doing this right now by adding a new implementation of the C10 tensor impl, which keeps track of this, and it wraps around the original tensor. So when we enter an operator, we can reshape the original tensor in order to give it to materialize the view, and then when we exit the operator, we can reshape back and copy it back into the original tensor in order to preserve any updates that have taken place there. This works for some basic things. Some things are currently not working correctly here. Like for example, being able to like the select operation doesn't work right now. There are some things that still need to be figured out, but this is working in a lot of ways. Another like really critical part of this design is that we want to make sure that the mechanisms that we employ here are applicable to compositional as strided. As strided has a bit of a is a bit more power than Vue does, because it can modify the offset as well as change the sizes and stride. So it can shrink the view, but it seems as though this approach will expand to that just fine. So that's kind of where we're at right now. I'll open to questions right now, if there are any.
I have a question, and this is mostly just me trying to understand like what this looks like from the perspective of tracing.
Okay.
Like, are we going to expect, so anytime you call a view that ordinarily would have failed, do we end up seeing like an extra clone and an extra copy, kind of as like the prologue and epilogue before the operation where you do something with that view afterwards?
Yes. I'm curious of what impact would that have on tracing? So what impact do we see right now with like negative view and conjugate view?
It's a bit of a hard question to answer because we don't really have the complex numbers working with PT2 right now. But I believe what I would expect to happen is I would expect to get a trace that doesn't have this concept. That would make the most sense because it seems unreasonable to expect backends to know about conjugate bits and handle them.
Okay.
Yeah, I think at the high level, is it like AOT dispatch? It's the difference between AOT autograph and AOT dispatch. AOT dispatch would actually resolve these kind of things.
Yes, I would expect it to all be resolved by the time you get to a backend.
And then I guess just the other thing is like this is I guess more of like a perf thing, but like let's say you take an infallible view of something that the original view would have failed with, and like therefore under the hood you have to do a copy, and then you use that tensor in like 20 different operations. Is the like end result of all of this basically like we do 20 copies, one for each place where the thing is used? And like maybe that doesn't matter, or corner case, or just curious.
Yeah, as it's currently implemented, the answer is yes. That's how it works.
This is, by the way, how conjugated negative views work.
Do we have any expectation of how often something like this would be used, Ed? Obviously not at all,
When you
but
get an infallible view, well, anywhere someone wrote a reshape call in their PyTorch program, that's a place where an infallible view might have been used
right.
instead if they do a view.
But I guess with reshape, the copy happens once instead of once for
Yes,
every.
if there's an explicit reshape, you would copy only once. So,
I
I
guess-
mean,
Yeah.
it might be a good idea to cache it. I don't know. One you can cache these things, but it's a bit annoying because then you have to make it thread safe, because multiple threads could view the same view at the same time. So that has to be done correctly in that case.
Hmm.
Brian?
I think that makes sense. It's like, so in my head, there's sort of like, there's the perf thing of like, what's better for perf, like only cloning once or like lazily cloning every time you need to. And then there's just the complexity thing of like, which of those designs is easier to implement. It's that like, would you agree that we're sort of saying that clone every time is the default easier thing to implement, and then it's sort of just additional extra work to get the better perf?
If if the better perf is caching, then yes, that would be additional work, and it would be more complex for the reasons Ed called out. Alternatively, I mean, the alternative is that people should write reshape instead of view if this is happening, and I guess that's not exactly a viable alternative if they actually want updates to this to propagate back to the original, right? So it's not like a one-to-one equivalence, right?
And to answer the original question, which is how often do we think this will happen, I don't think it's very common to mutate through a reshape call. That just doesn't seem like it happens ever, honestly.
Okay.
Any more questions?
Yeah, this is a kind of like us taking a step back one, just for understanding. So previously, if somebody tried a view and it didn't work, it'd be like, don't do this, use a reshape. But now, someone in eager can use this view, and it won't tell you that, right? Like it'll just be slower. So are we basically being like that is like a little BC breaking, or do we have like a warning, or how will people know? Oh, I shouldn't use a view, I should use a reshape.
That's a good question. Because right now, there would be no warning, and I don't know that we. I mean, I think it's a valid question. Like, is there a notion of like BC breaking for performance expectations? I think it's probably something that we want to consider at some point. But I guess like if you noticed a performance, I mean, like if you cared about performance, you'd be profiling, and I guess I think like I'm not really equipped to answer like how much we care about your performance. I think that it's I mean, a big part of obviously the PT2 effort is that there are better ways of achieving performance, right? So yeah, I guess like we could do like a warn once, right? Like warn once on like the first time an infallible view is generated, if we think that is, if like we are concerned about this and we think that someone might prefer to do a reshape. But yeah, I don't know. Ed, do you have any thoughts about this? Like how much we care about eager performance and
the both of the proposals that I heard so far seem reasonable. The proposal to add a warning or the proposal to implement the caching. These both seem to solve the performance problem. You might want to warn if someone is mutating through an infallible view, even if you're doing caching, because that's not cheap. But
right, because he's back.
but like, I mean, if you cache it, I also feel like that satisfies it because it'll be just as fast as a reshape. You just didn't tell the user about it.
Well, but you have to you have to recompute it if you mutate through the original as well.
Yes, but like, that also seems less likely to happen.
I'm just saying, like, that would be a complexity, an additional complexity with the caching approach, right?
Um,
It would be similar to kind of like the copy on write
well,
mechanism.
yeah, so if you want to cache it, then you need something like functionalization if you want to cache it, where you invalidate the cache when the original gets updated.
Okay.
It's a good question. Yes. So basically, we have something that previously didn't work, and now it works, but it runs slowly. But maybe it was better to raise an error. And all the suggestions, make it faster, raise a warning. These all seem reasonable. Because remember, the original point of stride agnostic PyTorch was to say, well, we are allowed to change the strides of operations, and we think it won't matter. But if it does matter, like for example, if you do a view, we'll still manage it. But probably you do want a warning to know that, hey, this view is no longer a view anymore.
Yeah. Yeah, or I don't know, or like we want to surface it in some kind of performance analysis tool, right? Like that could be an additional thing to do. Okay.
All right. Any more questions? Okay, let's move on then.
All right, thank you.
Okay, so I don't think there were any other proposals for topics. So we're going to loop around to PT2 escape hatches. Vaz also has a version of this doc, which we can also look at briefly. But what I wanted to first do was I wanted to present some stuff that Brian and I wrote into the doc about what are the motivations for these escape hatches. And then hopefully we can sort of mob the design a little bit in this meeting. Okay, so what are we talking about when we're talking about PyTorch 2 escape hatches? So there are a few things that have come up in the issue tracker / pull requests. Okay, so user story 1 is the export user story. So this case is I have some operator and I want to send it to my own runtime, right? Because my runtime understands this operator directly. I don't want it decomposed. But let's suppose that I do have an implementation of it in terms of regular PyTorch ops, and I want to go ahead and use that. So this is something that Onyx Export wanted. Their idea was, hey, if I can use TorchFX wrap with a function, then it would be nice if when I export it, I just get this function directly rather than the things that are inside the function itself. Does this use case make sense? So I'm exporting and I have an op that like calls a bunch of torch ops, but I don't want to decompose it. I just want to pass the undecomposed thing.
So is the idea that this op needs to exist in the basically when after you export it, the same version of this code is expected to be there?
The same version of this code is expected. Yeah, but maybe not like in terms of PyTorch error ops, but just you maybe have a fused kernel, or you just if you're Onyx, it's you would have exported it to the Onyx op corresponding with it, and some backend would have just implemented that directly.
Right. Okay.
Question: are we talking about eager or only export for this?
So we are talking about eager, but some of the user stories are export oriented. So this is an export oriented user story for PT2 custom ops.
Would you still expect to use that op even outside of PT2, like outside of doc compile, or is this a doc compile only notion?
Well, I mean, typically when you're exporting an Onyx model, you have a pre-existing PyTorch model that you can run, because often you're iterating with PyTorch as the front end, and then you want to export it to Onyx. So yes, you would want to run the compute in eager, but like in this example, they have an implementation of the custom activation, so they can just go ahead and run those ops if they're running it in PyTorch.
Yeah, the reason I was asking is because I was trying to figure out the difference between this and something like allow and graph, which basically makes a stub.
Yeah, good question. So that's why I'm starting with user stories, right? So hopefully the user story here is clear. Okay, here's a second user story, the Trident user story. So this situation is, hey, I love Trident. I'm OpenAI, and I like rewrote a bunch of my model with some custom Trident code. And now I want to put it in the middle of a bunch of PyTorch eager code, and I either want to just run it and use my Trident code when it can be used and use the other inductor optimizations otherwise, or maybe I want to export it, and then somehow the Trident code shows up as a black box operator. Any questions about this user story? I'll add that if I differentiated through this, the Trident code may typically be in a custom autograd function, because I'll need it backward as well for the Trident kernel. Okay, moving on to the third user story. So this user story is, hey, inductor's great, but I got some magic sauce in my backend. This can be a export backend. This can also be a eager backend. Like I am, MLIR, or I am, like Nirvana or whatever. And like for these particular ops, I've got a super duper awesome fuse kernel that's better than inductor. And I want to interpose when those things happen and then black box them so that inductor doesn't deal with it. Please don't do it, inductor. I've got a better, more awesome version of this, and I want to grab it for myself. And this is an issue filed by someone asking for this.
So why are all these not custom ops?
Oh, great question. Yeah, we'll get to that very shortly. I just want to talk about user stories, and then we'll do the custom off thing. Okay, and the last user story is this issue. It's sort of the same thing. So in this one is inductor sort of runs the graph, and there are just some black boxes that I've swapped out for my own implementations. This is sort of the reverse. It's I want to write my own backend, and I want to be in charge. But then when I have a bunch of code that I don't know how to deal with, I want to just pass it off to inductor and get inductor as the like fallback implementation when I can't deal with things. Because inductor is very good at coverage. It's sort of designed for that use case. These are very similar, and you could implement one the other way, but like I do think of it as a distinct use case as well. Any questions about user stories? Any more user stories people want to propose?
Do you want more user stories on all escape hatches, or only those cases where they want to preserve a whole block of logic for the backend?
The whole block of sorry, what's the other case you're referring to?
All the other cases where, say, they want to escape hatch where they want to say, oh, only this branch will happen, or they want to escape hatch of say they want to skip some code, all that, or do you want to only care about where they want to preserve a whole block of code as a black box to the backend?
Yeah, let me think. This is a great question, and it's because I named this escape hatches, it seems very reasonable. Let's focus on the black box situation. So let's call this PT2 black box escape hatch, just to narrow the discussion for now. Okay, so I want. Yes,
I had one quick one. If the sort of spirit of this is user knows better than compiler, one thing that came up on Dev Discuss that I've been pretending I didn't see is, can users delete guards within their backend that they know they don't want? This export is sort of reaching for things like this, but this is within eager. optimize, like they lower their compiler down, and then they get the graph and args, but they also want to get the guards and say, don't use these for this frame that you just sent me this graph module for. And we don't have any kind of answer for that, but there have been like 2 requests for this so far, framed a little bit differently. I can add the links to them in this doc.
Yeah, that would be great.
Yeah.
Okay. If we have time, I would like to circle back to these 2 questions, but I do feel they are a bit different than the other requests that we've been talking about so far. Okay, so returning to Razil's question. So Razil asked, why not just do this with custom operators? Okay, and let's just talk through how each of these user stories would be done with custom operators. So export user story, I want my own op. So what do? You define a new operator using Python operator registration, and then you carefully define where the decomp goes. I think when Brian and I worked this out, it should be a composite explicit autograd decomp. And you just have a custom op, and then you just tell the lowering process not to actually what's the word? Not to actually decompose the operator.
Decompose.
Yeah. In the Trident user story, same deal. You make a new custom op for your Trident operator, and you're done, basically. You just have a custom op, and it's your Trident thing. In the backend extension user story, this one is a little more tricky because it's not necessarily a function that you're black boxing. A lot of people want to black box NN modules. So this leads to Voz's comment about allowing graph, but we'll get there in a moment. If the backend wants to black box a function, then yes, we could just do the same playbook we did before. Something different has to happen for NN modules. And for the fallback to inductor user story, you know what? Let's also put this as sort of out of scope for this discussion for now. Okay, so custom operators doesn't work for NN modules, naively. And there's one more thing that I want to point out, which is that when you write a custom operator, we expect you to do a lot of things, right? In the limit, you might have to write a meta implementation. You might have to give CPU CUDA implementations. You might have to give an autograd implementation. There's a bunch of things you have to do. And so the API for defining custom operators is a bit wordier than, for example, what he wanted to do here, which is just, I got a function, I want a torch.fx wrap it, and call it a day. So there are a bunch of things that, you didn't have to do. For example, when you write a new operator, you need a schema, you need to give it a name, whereas torch.fx wrap, you just plop in the callable directly. And if you want autograd or functionalization to work, you need to actually give implementations for those as well. So the other thing that I would say about the custom operator API is it seems like there's some space for streamlining the API, where sometimes you don't need autograd because you're only working on an inference use case, or for example, you have a decomp in terms of eager operators. That means you don't have to write a meta function because you can just use the decomposition to do the meta function in that case. Or just simple things like, do we have to give an operator name? Actually, operator names are probably a good idea. So, we should force people to do them anyway. But do I have to give a schema? Maybe I can get the schema automatically. There's possible things like that. So that's some stuff that I would ask the room to think about.
Because to me, right, that would be a nicer solution, right? I just feel that we, this is the unit that we use to define computation and semantic. And I guess I'm trying to understand what something different would look like if it's not a custom op.
Yanan?
Yeah, I want to talk to the point about whether we need a schema or not. I think it would be necessary to have a schema because you need to understand the operator's behavior. Let's say if it's not functional, we need to figure out how to functionalize it. If we don't even have the schema, how do we do that? Otherwise, it's violating the spec.
That's right. And in a lot of cases, people will write operators that are functional, and sometimes they won't. But I mean, so right, it's just hard to think about how exactly you could have a API that's as slick as just slap a decorator on it and then you're done. This is a kind of interesting question, especially because a lot of functions like this will be functional. Any more comments?
I also feel like in the limit, it's like when you have the decomp to torch ops, hey, you can infer an autograd formula. You can maybe even infer a functionalization formula by seeing the schemas of the ops you're calling or something, but not entirely sure how hard that would be to get working. So it feels like in the limit, just the slick decorator seems like something that might be achievable, but it could be a lot of work.
Just to give a little more color on that, we could automatically infer an autograd formula by first differentiating it the internal torch operators, and then the main problem with just differentiating it is the intermediates may be used as part of the autograd formula. So then you could tell the user, hey, you have to return those intermediates as outputs, or you could just automatically recompute them from the inputs. Both are potential ways to just automatically generate an autograd formula. Okay, I want to swing over to Vaz's point about allow and graph. Okay, so what exactly is allow and graph? Actually, does someone want to tell us what allow and graph does? Vaz, do you want to tell us?
Sure. Allow and graph is an annotation that we have that is an escape hatch annotation. It lets you have any custom callable in a module that in an export or eager optimized module. So it lets you mark a function or a module at allow and graph, and then when we're tracing it, we don't proceed through it. We do some safety checks within it, but then in your end graph, you'll have that custom function available. So if I mark a function called foo, allow and graph, and inside is a bunch of ops, those ops won't get lifted into the top of the function. Your exported graph will just have a foo call in it.
And just to check a few things. So allow and graph doesn't preserve things through makeFX tracing. So if you pass in 8 ops, for example, to export, you wouldn't actually see the allow and graph in that case.
Say that again.
So I run export and I pass in 8 ops equals true, which asks me to makeFX lower it. It won't get preserved. Is that right?
Correct. Yeah, exactly.
One other comment. Hars?
I guess one thing I wanted to add is the fact that it does not affect makeFX is a feature and not a bug. For I think most of the uses, or for a lot of the intended uses of allow and graph. Basically, I think the primary intended use case I have in mind for allow and graph is this function is safe to trace through, but Dynamo cannot figure it out for one reason or another. And so we have a lot of cases like this today that I think we should already be recommending people use allow and graph for. Things like autograd.function, things like checkpointing, things like PyTorch transforms. All of these Dynamo don't really work with, but users should just be able to slap on an allow and graph and trace through it and compile it.
Michael So?
I just got here, but are we concerned? Allow and graph is a little inside baseball because it's basically you have to understand the difference between Dynamo. So somebody might have said this already, so stop me if they did. You have to understand the difference in how Dynamo traces things and makeFX traces things, which already the fact that there is Dynamo and makeFX is an internal detail.
Right. So my proposal would also be to change the name to traceable instead of allow and graph.
But like, then we have to kind of define like what does traceable mean? You know, like we understand obviously, but like I'm just a random user. Like, yeah, what does traceable mean? This is my main question.
I think to put it another way, like users are probably just going to try putting it, if we aren't really careful, what it's going to mean is everyone's going to get the idea that if something doesn't work on the first try with Dynamo, they should just put allowing graph on their thing. And then they're going to report us other bugs that like, why did my program do something unsafe? Or like, I don't know if people will understand exactly what this means or understand how to determine if their function is safe.
I think like the tracing contract is like a relatively well-known contract.
It's not even safe for tracing, in that it doesn't accumulate guards for what happened within it, right? So you're not like if you actually do something inside that requires specialization, you're kind of SOL and you hope it all works out. The post I put on top talks about a lot of this. Richard Zhu isn't here, but he also had a lot of concerns about making this a more widely used API. I'm more for it ever since Forrest really started campaigning for it, but I do think we need to, explain a lot of these caveats.
Yeah, can you like point me at the place where the tracing contract is?
I think Horace is just talking about how Jax is like tracing.
Well, I mean, it's not even just.
I know. I'm being facetious, but we're like it's fairly well known and obvious and like not documented anywhere. Those things don't add up, right?
No. I'm saying that it's like the exact same contract as like jax.jit or fx.symbolic_trace or jit.trace. Like,
Those have different APIs
though.
Those also don't all have the same contract around tracing.
They have pretty similar contracts. Or like.
But like, you're making my point for me, right? I'm like, it's like.
Well, no, I'm disagreeing with Mike.
Are not well. There's a lot of details that are not well known.
Well, like, so like my thing is, I'm okay. Like, I believe that it is definable, right? And we can get to a point where people mostly have a mental model to understand what it is, but we're not there yet. And also, we should just call it like unsafe trace or something.
Sure. I'm fine with calling it unsafe trace, but like my point is like I think this is like definitely needed. It's like I think like the stupidest situation for users to be in is cases where they know there's no reason it shouldn't work, but it doesn't work. And I think allowing graph is like the easiest way for us to like just mostly resolve all those situations. Yeah, like where the user can just like override cases where they know it should work, but it doesn't actually work.
Any more comments? Yes, Raziel.
So sorry, I'm not familiar. What does the contract for a custom callable is? Like how will be preserved in the graph? How then that graph will be then
Are we still talking about allowing graph?
Yeah.
Okay. Let me try to elaborate the contract right here, right now. So the contract for allowing graph is let me think. It will be preserved by Dynamo and not by any further parts of the pipeline. If you are a eager user, to be correct, the callable must be traceable with makeeffects manually, and the trace produced must be valid for all subsequent calls, cannot conditional on changing global state, cannot modify Python global state. Non-requirements include mutation is okay, tensor mutation is okay, I think. not necessary to write an autograd formula. Anyone want to add anything to this?
You should probably define what valid means in the context of a trace.
Must when must be observationally equivalent to running the original eager code for all subsequent calls.
It can add shape guards.
Yeah, so guards on shapes are okay as they will be captured by the tracing mechanism. Because MakeFX does know how to handle this. Rizil, does that answer the question?
I can't really like reason out why it doesn't go through MakeFX. Like I understand that implementation wise why, and that's why you want it, but like if I were a user,
Yeah, you'd be like, why? Why not? And so
Yeah.
I mean, intuitively, the reason why it doesn't go through MakeFX automatically is, well, it could if you only did inference and yeah, if you were only doing inference and you didn't really care about like having a schema or an operator name because we could automatically work that out, then I think the answer is yes, you could preserve it all the way through. And the way you would preserve it all the way through is you would turn it into a custom operator and fill in default implementations of like how to do autograd, how to do functionalization, and then you would be able to preserve it past MakeFX. But that like streamlined API doesn't exist. So in practice, it gets stuck. It evaporates at that point. Does anyone want to propose we do something? Because if I just say, well, we tell users allow in graph, maybe we rename it, whatever, and we tell users custom operators, like that is a plan of action. It requires very little work from our part, but I do feel like it, doesn't, like for example, Greg's question just now, it isn't really resolved. You still have to know the inside baseball thing, as Svo puts it.
I mean, I think these two things as like the basis of our strategy here is fine. I think they both do. They're not the same thing, so we shouldn't do just one or the other. I'm a little bit more worried about allowing graph in terms of. I agree that it's like possible to explain, but we don't have to. We haven't explained it today. So, okay, both of them require some additional work, like packaging style work. Like, what do you need to do? What are the rules? What are the semantics? But not a lot of fundamental work. I think this is good. So we should do both of them. And then the export work stream should commit to like doing the sort of packaging-ish work. And the core work stream should commit to shaving down whatever insane, blades that we find while doing the packaging work. Does that seem reasonable?
Sorry, when you say packaging work, I thought it was the user's packaging work where they package some code into a.
Right, I mean like productization work. Okay, let's have like an API as well as like a set of defined things that you need to do and all the sort of necessary information and documentation and rationalization implied by that. Right.
So actually, Michael, let me just push you on that a little. So what if I said, as far as the API goes, we have exactly allow in graph as it exists today, and we have exactly the custom operators API as it exists today.
No, I think like we need to have, I don't know. So the thing is, I don't know if I'm going to run into some razor blade while doing it that we want to fix. Right. So
Well, but
I don't.
I just define an API for you. So I think it
No.
like this is another API. We don't have this API does not work. Like you have no way of just doing this. Do we want this API to work?
No. I don't want we can get an arbitrary Python callable in the graph that then we expect to export somehow to a non-Python system. Like it just doesn't make sense, right? I mean, it makes sense for Dynamo, other Dynamo, but it doesn't make sense for export.
It could make sense for export where you have that, and then you look for it in the graph and like an FX pass after, and you write it into your own thing. You just know, hey, when I see this during lowering or my equivalent of executor's pipeline, I rewrite it to be this like native callable, or this is like a hint that I then remove.
Yeah, I think you should have just used a custom op then, you know?
Yeah, that's what I think. Yeah.
Like, I think you should be pretty explicit about that. I think it is, you're right that that's additional functionality, which can be nice in certain circumstances. But like, I'm just trying to imagine how like the ads model transformation service will end up consuming this. And I'm like, no, I actually would prefer something more structured there.
I think custom op is, this just sort of feels like a step towards custom. Like custom op feels like a more power user feature. A lot of people want to just allow and graph a thing, and they don't know what it means to.
Yeah, but then they have to do something to it, which may include writing a native implementation anyway. So, you know, I don't know.
Maybe you can also just use it to get through graph breaks to see what your whole graph looks like. So you can just like pepper and allow graphs and like your autograph functions or whatever, and then get a feel for what that graph looks like. And then you know you have like these 4 call sites to fix.
Well, so allow and graph and FX wrap are different, right? Because allow and graph will do the sort of like baseline FX or baseline whatever, make FX tracing, there you go, and then do it. What wrap is like I preserve a name that corresponds to a Python name that then I can call, like, you know, when I execute the graph, I call that Python name, which I don't.
Sure. I guess I'm saying is it's a good way to proceed when you're stuck on graph breaks during export, but maybe not a good long-term production feature. So it's worth having, if only for that, and you call it like unsafe or something like that.
You know?
Right. I just trying to understand. So first of all, I'm also for the custom op solution. But where does this user constraint come from? Operator is kind of the commonly accepted name for a canned function. And if they want a custom function, then that's a custom op. Like, why do they not want a custom op?
Okay, well, let's look at the user stories to try to find out. So, for example, Onyx. They don't really care about defining a custom op as far as Torch script is concerned, because they've got their own Onyx op definition. And why duplicate work? Like, I just need to get the function over to the converter, and then I'll, you know, normalize it into some happy schema. So that's why Onyx would say they don't need it.
Yeah, if I can speak for Onyx for a moment, like I think what export user want is just the function semantic. You just need this function to be preserved as a node in a graph. You actually doesn't care whether you have a kernel to run it in Python eager. So I feel like what we need is a custom op, but simple. Like you don't need additional functionality that, you know, I need to worry about autograd, I need to worry about running this in eager. I just want this to be, say, for this whole function, preserve the original semantic and then give me in the graph. All the other things, if I can skip, I would like to skip.
So that's why I was kind of in favor of having a simpler way to custom up. I mean, it's a tricky thing because it has to still then, I mean, I don't want to dilute what the structure of a custom up is, but I don't know if there is some safe things that we can do to make it simpler to do a custom app that doesn't, basically that meets that criteria.
Yanon?
I just want to keep the programming model simpler for us. If you want something that's functional and effectively a function, that's an op. If you want something can be preserved, and potentially not functional, that's a module. And we don't even have the concept of function call really in the captured graph. If they want to preserve this, then that's not supported. Can we say it's not supported and have them choose a different option to keep the programming interface simpler?
I feel that I can satisfy both parties here, whereby whatever the stream, what did Sherlock say? The simplified custom op API is, it should still map to a proper custom op. And so in that sense, we haven't made the backend story more complicated because every one of these simple custom ops can be mapped to the regular model. You know?
And the custom op registration API be simpler though. If it can be simpler and we can still have all the information, then the custom op API should just be simpler. There shouldn't be a simpler version of custom op registration API, in addition to the current more complex one.
No, that's a good question. So a little bit of a historical note, the Python op registration API is modeled off the C++ custom op registration API, which is modeled off of PyBind 11. And we've had that for a pretty long time. And let's see. The API was also constrained by the fact that it needed to be decently fast for eager mode execution, which is not really a constraint here. And it's also constrained by the fact that it had to work in C++. So whatever we do, I doubt we're doing a redesign of the C++ registration API. So, I mean, I feel you're going to have two APIs one way or another.
Also, I feel like if we can have the custom op story unified with inductor, that would be good. Because like in the last user story, what Triton actually want is basically to have a custom op and pass it into inductor, but have the inductor keep it as opaque, just don't touch it. So if you can have a way to author a custom op and pass it along through Dynamo, MakeFX, and inductor in a holistic way, it might be easier for user.
To be clear though, a custom op has that property, except maybe that it's a little expensive to call because you know, the ops are not very fast. But besides that.
Yeah, like I think custom op does, like the Python custom op today does have that property, but people tries to come up with new ways to not use custom op, like because it's probably too complicated to author a custom op in a functional way, in the right way. Like backend another requirement for backend is they somehow carve out a subgraph and then say, this is my black box. I want to treat this as a black box. Then I need to define a custom op on the fly. And it's not exactly easy to do that.
Wait, but shouldn't that happen after you exported the graph? Where you exported the program, then you look at what thing.
Yeah, the scenario I'm talking about is like one DAN trying to plug into PT2 backend, and they want to do the partition first, form a subgraph, and then turn it into a custom op, and then use inductor as fallback. But it's not exactly easy to do that. You need to be able to define a custom op on the fly, dynamically.
By the way, when export does this is like delegates, right?
Yeah, exactly.
Yes.
I mean, you export it, then you process the export.
Okay, in the 1 minute we have
And
left.
it's more analogous to the kind of eager delegate API, where they process one module first, maybe through export, and then export the entire module. It's not exactly on the fly, but should satisfy the need here.
Okay, in the minute we have left, I want to understand what the next steps are here. And who here has a like vested interest in like making this happen sooner rather than later?
I guess Vic and I should have interest in it.
Well, I have an interest in allowing graph existing.
And the thing I feel like is missing is some sort of hypothesis about like how difficult it would be to beef up the custom opt stuff in a better way. Like I think what like Horace's angle on allowing graph and like maybe documenting some of the traceability requirements makes sense. I think like what Michael said about some productization on export makes sense. We don't really have data on like the other side as far as I understand. Does that make sense?
Yeah, that's right. Okay, well then, I will tentatively defer to Yanon and Avik about this side of things, but I'm not, to be clear, I'm not signing you up to do anything. I'm just like, if people want to know if we've actually done anything, I will point them at you. And it sounds like we'll just have to leave this open as we have some alignment on what things are reasonable to do, but we don't have anyone actually signed up to do these things. And I also agree with Greg that there's some more research necessary on, I guess I'll call this simplified op definition. Simplified custom ops. Any last words from anyone? All right. Thanks, everyone. See you all next week.
Thank you.